Good morning, all of you. Today we are going to start fifth unit. In fifth unit, today's class we are going to discuss about distributed file systems. So, in fifth unit, part of fifth unit consists of the introduction, file service architecture, DFS, that is distributed file system, case studies. We are going to see two case studies here. One is Sun NFS, that is Sun network file system. Second case study is the Andrew file system. So today's class we are going to see the introduction and the distributed file system introduction and the file service architecture. These two topics only we are going to discuss for the today's class. Introduction about NFS, file distributed file system, DFS. File system were originally developed for centralized computer systems and desktop computers. So the file systems are actually developed for the desktop computers and the centralized computers which are in the network. The file system was an operating system facility providing a convenient programming interface to disk storage. So it acts as the file system acts as operating system by providing a convenient programming interface to the disk storage. Distributed file systems support the sharing of information in the form of files and hardware resources. So information is shared here in distributed file system in the form of files and hardware resources. We are going to concentrate on how the information is shared in the form of files in the distributed systems. This is what we are going to see. With the advent of distributed object systems, so the distributed object systems are Corba and Java and the web also. The picture has become more complex. So with the advent of distributed object systems and the web, the distributed file system has become more complex. Figure 1 provides an overview of types of storage system. So these are the types of storage system. They are main memory, file system, distributed file system, web. In web also we can store information, distributed shared memory, remote objects. Remote objects are called RMI. RMI is in Java, remote method invocation, and ORB is object request broker, which is in Corba. Then persistent object store and peer-to-peer storage system. These are the storage systems available. So we are discussing here about sharing, persistence, distributed cache, consistency maintenance, and example for each storage system. By taking this main memory, if you take the main memory, there is no sharing, there is no persistence, there is no distributed cache in main memory, and there will be one stick copy of the main memory, that is consistency maintenance. Example for main memory is a RAM, a random access memory. And second one, file system. For file system cannot be shared and it is persistence. Persistence will be there in the file system. The file system, the distributed cache will not be there. and there will be one strict copy of file system in the consistency maintenance. Example for file system is Unix file system we can take. And third one, distributed file system. The distributed file system can be shared and it is persistent, and distributed cache will be there in the distributed file system, and the consistency maintenance will also be there. Example for distributed file system is Sun network file system. And the fourth one, web. Web can be, the information in the web can be shared and it is persistence, and distributed cache will be there, and there is no consistency maintenance in the web. Example is web server, where the websites are stored. Next one, distributed shared memory. So here sharing will be there, information can be shared, there is no persistent, and distributed caches will be there, and consistency maintenance will also be there. So example is IBY CH18 is the example. Next one, remote objects. Sharing will be there, but there is no persistent and there is no distributed cache, and there will be one stick copy of the remote object. Example is Corba. Persistent object store. Next one, it can be shareable, it is persistent, and there is no distributed cache, and there will be one copy of that persistent object store. Example is Corba persistent object service. And last one, peer-to-peer storage system. This is shareable, and there is a persistence and distributed caches will be there, and consistency maintenance will also be there. Example is Ocean Store. So these are the storage systems available. File systems are responsible for the organization, storage, retrieval, naming, sharing, and protection of files. Files contain both data and attributes. A typical attribute record structure is illustrated in the next figure. See this is the file attribute record structure. First is file length, then creation timestamp, read timestamp, write timestamp, attribute timestamp, reference count will be there, and who is the owner of the file, and what is the type of the file, and access control list will be there for a particular file. Distributed file system requirements. So what are the distributed file system requirements? The requirements are transparency, concurrency, replication, heterogeneity, fault tolerance, consistency, security, and efficiency. These are the requirements of distributed file system. File service architecture. An architecture that offers a clear separation of the main concerns in providing access to files is obtained by structuring the file service as three components. The three components are flat file service, directory service, and client module. The relevant modules and the relationships are shown in the next figure. See this is the file service architecture. The left is client computer, the right side is the server computer. In between this is connected with the client, and servers are connected with the network. So in the client part, application programs will be there, and client module will be there. And coming to server computer, directory service will be there, and flat file service will be there in the server computer. The client module implements exported interfaces by flat file and directory services on server side. Responsibilities of various modules can be defined as follows. Flat file service. What are the responsibility? Concerned with the flat file service, concerned with the implementation of operations on the contents of the file. Unique file identifiers, they are called UFIDs. Unique file identifiers are used to refer to files in all requests for flat file service operations. So in flat file service operations, there will be a unique file identifier for each file. The unique file identifiers are long sequences of bits chosen so that each file has a unique among all of the files in the distributed system. So whatever the number of files in the distributed system, and there will be a unique ID for the file which are available in the distributed system. Directory service. Coming to directory service, it provides mapping between text names, the file names, for the files and their unique file identifiers. Clients may obtain the unique file identifier of a file by quoting its text name to directory service. Directory service supports functions needed for it and generate directories, and it generates directories to add new files to the directories. So in fifth unit, part of fifth unit consists of the introduction, file service architecture, DFS, that is distributed file system, case studies. We are going to see two case studies here. One is Sun NFS, that is Sun network file system. Second case study is the Andrew file system. So today's class we are going to see the introduction and the distributed file system introduction, and introduction about NFS, file distributed file system, DFS, file system where distributed file systems support the sharing of information in the form of files and hardware resources. So information is shared here in distributed file system in the form of files and hardware resources. We are going to concentrate on the how the information is shared in the form of files in the distributed systems. This is what we are going to see. With the advent of distributed object systems, so the distributed object systems are Corba and Java, and the web also. The picture has become more complex. So with the advent of distributed object systems and the web, the distributed file system has become more complex. Figure 1 provides an overview of types of storage system. And coming to access control, in distributed implementations, access rights checks have to be performed at the server because the server remote procedure call interface is an otherwise unprotected point of access to files. Directory service interface. So the next figure contains a definition of the remote procedure call interface to a directory service. Here lookup function, lookup directory comma name. It returns the field. It throws not found exception. Locates the text name in the directory and returns the relevant unique file identifier. If name is not in the directory, this function throws an exception. And next function is add name directory comma name comma file. If name is not in the directory, adds name comma file to the directory and updates the files attribute record. If the name is already in the directory, this function throws an exception. Un name directory comma name function. If name is in the directory, the entry containing name is removed from the directory. If name is not in the directory, this function throws an exception. Next function, get names directory comma pattern. It returns name sequences. It returns all the text names in the directory that match the regular expression pattern. See this is the file attribute record structure. First is file length, then creation timestamp, read timestamp, write timestamp, attribute timestamp, reference count will be there, and who is the owner of the file, and what is the type of the file, and access control list will be there for a particular file. So for globally unique, the file group ID will be having 48 bits. The 32 bits are used for representing the IP address of the particular machine, and 16 bits are used to represent the date.